Alright, so I thought I would start with the main.py file, and this file sets up the FastAPI app with async database access, structured logging, and type-safe models. You can see we're using FastAPI, SQLAlchemy, Pydantic, and structlog. The rest are standard Python libraries, nothing too crazy there. So let's start off with structlog.configure, and then we got a processes list of how we want our logs to be structured. Now, why are we using this instead of like the conventional logger? Well, if you're using the conventional logger, number one, you'll be getting all the logs that are there, potentially recording every single log. Number two, you would be getting everything back in string, so you have less control on how you shape and manipulate the data. So in a more like professional environment, you'd probably want to use something like structlog instead of logger. And if we look at this, how I've structured this, we can, instead of logging everything, we can filter by level, and then we can also add a tag so that each log has a logger name, and we can go a step further and add a log level. And obviously by adding a log level based on the parameters that you set, you can filter by that level. And then we've got a normal positional arguments formatter that is old school. It's just a preference, nothing too fancy there. And then we've got timestamper that takes the time in a string format and formats it in a consistent manner with FMT equals ISO. And then we've got stack info renderer and format X info. These are ways to really deep dive into a problem. So if you need to debug a specific log, these two would be extremely vital. Finally, we've got a Unicode decoder. Benefit of that is that you can handle edge cases like emojis, and then we've got a JSON renderer so that we're returning it in a JSON format. Interesting enough, logger equals structlog.getLogger returns the results in a key value store type style, and JSON renderer wraps it in a nice JSON format so that we've got nice logs that are perfect for like Datadog or Kibana, AlkStack, etc., etc. Then we create our FastAPI app with proper configurations. Now, we don't actually have documentations for doc.url and read.url. This is just to show a concept where you can have detailed documentation within the application, and you can make sure it doesn't reach production. So if it's developer or staging, you'll be able to find the documentation, which is great for a development experience. However, in production, we can make sure that this is not visible because it will be a security risk. You do not want people to fully understand and find ways to exploit your API endpoints, for example. And then we've got read aloud origin and host from env var. So we're using env variables. At the moment, they're fallback for localhost. And one is like, obviously there are two levels to this. We've got the core side. So we're protecting us against domains that on the client side that we should not allow. And you should probably always have allow credentials equals false unless there's a special use case for it, because you're basically avoiding cross-origin cookie risks. And then we've also got a wildcard at the moment, which we probably want to change in production, but for a development environment, it's okay, I guess. And then obviously separately, we've got the TrustedHost middleware, and this protects us against untrustworthy domains on the server side, so it protects us from phishing and spoofing, etc., etc. So these are just two layers of protection off the bat. And then we've got our Pydantic model with proper validation, where we're using Pydantic's base model, and we're basically structuring think of Pydantic as a way to structure, serialize, and format the data in a way that makes most sense. It's almost like a more sophisticated TypeScript solution. And we're saying the user ID needs to be an int, total transactions needs to be an int, total amount needs to be decimals, and average transaction amount needs to be decimals as well. We've got descriptions here that could be great for documentation down the road, but let's continue. Class is the same, they need to be strings. And let's get into the request response logging middleware. So once it's passed the test that it's allowed, we obviously in production probably want to change this to HTTPS, but for now it's HTTP, and we log when a request is made. The start time equals time. And and in short, we record various bits of information that's important. And then we also got response equals await call next. And this is, we use this call next is tracking how long it took from making the request to from receiving a response in the FastAPI application. And over here we got process underscore time equals time minus start time, and it says request completed. And yeah, it's self-explanatory. Then we've got app.get. Now we're using the root over here, async def root. And this is just to do a basic heartbeat health check to see if the FastAPI application is running. It's nothing fancy. And then straight after that, /health, we are doing a basic heartbeat, like a pulse detection to see if the database is running using select one. The benefit of using select one is that we're not actually touching any data tables or anything. We're just confirming that the connection is healthy. And obviously, if it's not healthy, we will get a 503 error, which would be a service unhealthy error. If we look at our API endpoint, we've got two API endpoints. One is for transactions user ID summary. And this one basically says, if everything is good, the response model will give you the transaction summary based on the configuration we set up in Pydantic. And you will get a 404 if no users were found based on your filtering criteria. 422 if there's a validation error. Example of a validation error will come up shortly, but if your start date is higher than your end date, there'll be a validation error. And for pretty much everything else, it's a 500. We could possibly drill deeper down and create more error codes for specific use cases, but I didn't see a need to over-engineer without understanding those use cases, so I thought a 500 made the most sense here. And then we've got async def get transaction summary. So this is when we trying to get the transaction summary. User ID needs to be an int. Here's something interesting. We're using Pydantic. It needs to be greater than 0, the user ID, so it can't be negative or 0, which is important, or else it won't even make the request. Same for the start date and end date. And these are all performance optimization things because you want to make sure that the requests are valid before you make the requests. And for example, dates need to be YYYY-MM-DD. And then we can create the async session depends on getDB, which is extremely useful. I will dive deeper into that when we cover yields. Obviously, this is just a comment explaining kind of what I said. Yeah, it does. It is optional. There we go. And it will try and validate. And if the start date is greater than the end date, it's a 422. Build query with proper filtering. Yeah, so it obviously needs the transactions.userid, which is required. Then it will run computations to get the func count, the func.sum, and the func.average. So it can work out these computational levels, and it will make sure that the transaction.userid equals the user ID when running those computations. And optionally, it could also filter it by a start and end date, provided the format matches what's expected. And then we've got query equals query.group by transaction.userid, which makes the most sense. And it will execute the query with a timeout. So results equals await db execute query, row equals results.first. Now you're probably wondering, why are we using results.first here instead of something like results.all? Well, if you use results.all, you'll probably get a list back, which is inefficient, where by using results.first, because we also running computations for count, sum, and average, we can get everything in one row, which is a lot cleaner. And obviously, if no users were found, it's a 404, which is not an error in the database. It just means there's no data for what you filtered, which is perfectly reasonable. And the way we handle null values safely is, instead of saying accepting null, we convert the null into decimal 0, which is also another way of saying nothing. And that's just a safe way to handle it. It's unlikely that this would ever happen based on our ingestion process, but it's just an extra layer of safety. And then we've got our response transaction summary. And you'll notice that we also, for the total amount and average transaction amount, we are rounding to the second decimal place because we're using currency. And then we finally got our logger.info transaction summary retrieved, and it gives more information around that. And if there's an error, it'll be using HTTP exception, and it will give a 500, which makes sense. We can obviously break that down further if needed down the road. Then we've got our second API endpoint, which is api.get / transactions / user ID, which is dynamic, and / transactions. And yeah, we can do async def get _users _transactions. And we're using Pydantic to make sure that certain conditions are met before we even try and touch the database. For example, the user ID needs to be greater than 0, so it can't be 0 or negative, or else that's a mistake. We also say that if we are making a request to the database, the expected request is 100 results. It needs to be greater or equal to 1. If it's 0, it obviously can't return anything. And if it's less or equal to 1,000, it will still show, but if it's greater than 1,000, it won't even try and attempt to retrieve those results because in this thing. So this might be reconfigured in production based on the expected use case. Remember, this is per user ID. If users are expected to have more than 1,000 transactions on the account, then this might need to be reconsidered. And then we're obviously using the async session. So basically, each database call is locked into a session. And in short, sorry, lost my train of thought there. So it's obviously using get DB. So DB session is provided by depends get DB, and we're using yield for automatic cleanup and isolation per request, which is just a nice little safeguard. All requests and responses are logged with methods like URL, duration, and status, and errors are logged contextually, including the user ID if available. So which is quite useful. Where were we? I'm just trying to go over this quickly. Count query, check if user has any transactions. Well, so it's going to be a 404. That makes sense. It's the same thing that we had before. And if we just go through the rest of this, it's very similar to what we've already discussed. I'm not sure if it makes sense to go over it. Obviously, the limit and offset helps with pagination. The pagination system we have, I think we can improve it, but based on the time frame, I thought this was a reasonable solution to build. Yeah, I think that's pretty much it. If you get pagination transaction query equals select transaction dot where transaction dot user ID equals user order by, and this is important. You've got to order your transactions. If you don't, it's going to really mess up pagination. So this makes a lot of sense to order by transaction date descending, so that they are structured, which is extremely useful. Else you might see the same results on different paginations. It won't be that useful. And then we've got results equals await DB execution query, transactions equals SQLAlchemy.all, and what we're expecting is a certain format. We've got the user ID, transactions with key bits of information. You'll notice that we're using a float, which is probably not the most accurate approach, but reasonable for what it's doing. I mean, we could argue that we could possibly change that with a bit more engineering. And then obviously pagination has a total count, a limit, an offset, and obviously the calculation needs to be that the offset plus the limit needs to be less than the total count, or else there won't be more pagination. And that is the main.py file. If we want to look at the DAG, this is another large file, but I'm going to leave it at this. I've already been speaking for over 10 minutes, and I think my overview kind of explained it, and the main.py file is the main file. Obviously, we've got database.py, config.py, security.py that would probably transform into Redis most likely, and then ETL transactions.py, which is the system I kind of explained quite well on the whiteboard.